On the screen is all of my working out for part A and B. I'll talk you through that and then I'll show you part C and D as well. So part A asks us to express f of x in the form r cos x plus alpha. So the first thing I've done is I've written out the cos addition formulae from the formula booklet. And we are multiplying that by r. I've replaced the a with an x and the b with an alpha. So we've got r cos x cos alpha minus r sine x sine alpha. The next thing I'm doing is I'm comparing that to f of x, what we were told to write in this form. I can see that I've got a cos x at the front here that matches up with this cos x here, which means that this r cos alpha is going to have to be equal to this root 3, which is what I've written underneath. Then, comparing over on the next term, we've got a sine x here and a sine x here, which means that the r sine alpha is going to be equal to 1, because it's like there's a little imaginary 1 in front of that sine x there. So that's what I've written there. Right. Next thing I've done is I've divided both sides by r, so that I'm able to think of this as a little right angle triangle where this is the adjacent and this is the hypotenuse, this is the opposite, and this is the hypotenuse. So as you can see, I've drawn a right angle triangle with roots 3 on the adjacent side, 1 on the opposite side, and r on the hypotenuse, which allows me to do a little bit of Pythagoras to work out that r needs to be 2. To work out the alpha, I've said that tan alpha is the opposite divided by the adjacent, so 1 divided by root 3. Tan inverse of that is pi over 6. So if r is 2 and alpha is pi over 6, then this will be the same thing as this. So therefore I can rewrite f of x as 2 cos x plus pi over 6. So that's part A done. Part B says to state the maximum value of f of x. Well, the maximum value is going to be 2, because I know that the maximum cos can be is 1, and 2 times 1 is 2. So the maximum is 2. And I need to state the smallest positive value of x when that maximum occurs. Now I know that the maximum of cos appears at either 0, or 2 pi, or 4 pi, or 6 pi, and so on, and so on, and so on. So that would mean that x plus pi over 6 will need to equal either 0, or 2 pi, or 4 pi, and so on. Therefore, I'll subtract pi over 6 from each of those to work out just what the x is. So 0 take away pi over 6 is minus pi over 6. 2 pi take away pi over 6 is 11 pi over 6, and so on. And we wanted the smallest positive value. So we're ignoring that negative value, and 11 pi over 6 will be the smallest positive value of x when that maximum of 2 occurs. Right, moving to part C of this question. We've been given this model, which is for the depth of water in a harbour. And I'm comparing this to what I've just done previously. I can see we've got a 13 at the front, that's new. But all of this here looks very familiar to what we've done in part A and B. The only difference is, instead of the x, we've got this pi t over 6. So, as you can see up here in the top right, I've got the 13 at the front. And then I've just taken my answer from part A and just swapped the x to be pi t over 6. So basically I'm saying that this is exactly the same as this. And the question's asking us to work out the maximum depth of the water. Well, I know that the maximum of this is going to be 2, plus the 13 is 15. And similar to before, when does that, so we need to find the time when that maximum depth occurs. When do we have a maximum with the cos graph? We have a maximum when this is going to equal either 0, 2 pi or 4 pi. So if we subtract pi over 6 from each of those like we did before, that gives these values here. And then, because of the 6 here, we're going to times all of those by 6, which is going to cancel out this, this, and this. We're then going to divide everything through by pi, which is going to give -1, 11, 23, and so on. So t is either -1, which isn't valid for what we're talking about. T is 11 or t is 23. I'm going to give the first value. The question does say find a time, so I could give 23 if I wish. But I'm going to give 11 as the first time, so when t is 11, just remember t is the time in hours since midnight. 11 hours after midnight is 11 a.m. in the morning. So that is part C of this question. Moving on to part D, we're told to find the times when the depth of the water is 12 meters. So I've taken my equation from, let me just tidy that up. Taking this equation here, and we're going to make that equal to 12 meters. So as you can see, I've plugged 12 in instead of the D. We're going to solve that equation. So as you can see, I have subtracted the 13 from both sides. So the 12 minus the 13 is the -1. I'm then dividing both sides by 2. So the -1 divided by the 2 is -1/2. So that's got me to this stage. Then I've done cos inverse of -1/2. And the first answer on my calculator was 2 pi over 3. I'm then using my graph to find other answers that it could be. So here is my first answer at 2 pi over 3. This will be the next answer, which will be 2 pi minus 2 pi over 3, which is the 4 pi over 3. We've then got 2 pi plus 2 pi over 3, which is the 8 pi over 3. I've then got 4 pi minus 2 pi over 3, which is the 10 pi over 3. And then finally I've got the 4 pi plus 2 pi over 3, which is 14 pi over 3. And I stopped there. I could keep going. I might have found too many answers here. I might have found not enough, but hopefully 5 is going to be enough. We'll see when we get to the end of the question whether we need to find some more answers or whether that is enough. Next, I've subtracted the pi over 6 from both sides. So subtracted pi over 6 from each of these answers. Then I'm going to times everything by 6 to get rid of this. And then I'm going to divide everything by pi, and that gives me the values of t as 3, 7, 15, 19, and 27. Just going back to check to see if I've found too many solutions or not enough solutions. Remember, t should have been between 0 and 24. So that answer of 27, I didn't need that, but better to find too many solutions than not enough. So I'm going to cross that solution off. So t is 3, 7, 15, or 19. Remember that those are the number of hours since midnight. So we have 3 hours after midnight, so 3 in the morning, 7 in the morning, 3 in the afternoon, or 7 in the evening. And those are the 4 times when the depth of the water in the harbour is 12 metres.